Hello, my dear students. Exams are just around the corner. So let's quickly master the triangles chapter together, okay? Tension nahi lena. We are going to make this super simple.
Okay, so first things first, let's talk about congruent figures. Just think of two identical 10 rupee coins. If you put one right on top of the other, they cover each other perfectly, right? That's exactly what congruent means. Figures that are equal in every single way. Same shape, same size. So when we apply this idea to triangles, it's the same thing. Two triangles are congruent if they are basically perfect photocopies of each other. This means all three of their matching sides are equal, and all three of their matching angles are equal. That's, 6 different parts to check. But wait a minute, checking all 6 parts every single time you solve a problem? No way, especially not in an exam. That would take forever. The good news is, we have some magic rules, some amazing shortcuts that let us prove triangles are congruent by checking only 3 parts. So let's learn these magic spells. We're going to start with the first two, and honestly, these are the ones you'll probably use the most, SAS and ASA. So our first rule is SAS, which stands for side, angle, side. Now, the most important thing here, the thing you absolutely have to remember, is that the angle must be included. That means it has to be sandwiched right there between the two sides you're looking at. Just think of it like a sandwich. You have a side, then the angle, then the other side. Let's look at this picture to really get it. So if we know that side AB is equal to side PQ, and side BC is equal to side QR, the key is the angle that's between them. If angle B is equal to angle Q, then we have our pattern. Side, then angle, then side. That's it. By the SAS rule, these triangles are congruent. All right, let's try a real problem. The question says we are given that OA equals OB and OD equals OC. Okay, so first we have a side, OA equals OB. That's given. Then we have another side, OD equals OC, also given. Now, what about the angle between them? Look closely at the picture. Angle AOD and angle BOC are vertically opposite angles, which means they are always equal. So there we have it. Side, angle, side. And so, by the SAS rule, the triangles are congruent. See? It's simple. Now, here's the best part. Once you prove that two triangles are congruent, you unlock a fantastic superpower in geometry. This is what makes it all worth it. And what is that superpower? It's called CPCT. It stands for Corresponding Parts of Congruent Triangles Are Equal. It's just a fancy way of saying that once you've proved the triangles are perfect copies, then all their other matching parts must also be equal. The other sides, the other angles, everything. Okay, listen up. This is a very important warning for your exams. SAS is your best friend, but SSA, or side-side angle, that's a trap. If the angle is not included, if it's not between the two sides, the rule doesn't work. Look at the slide. SAS gets a nice green tick, but SSA gets a big red cross. So remember, never, ever use this in a proof. All right, on to magic spell number 2. This one is ASA, angle, side, angle. And just like before, the word included is key. This time, it's the side that has to be included, or sandwiched, right between the two angles. It's the one side that both of the angles touch. Let's see how the ASA rule looks. So, if angle B is equal to angle E, and angle C is equal to angle F, you just have to check the side that's between them. Is side BC equal to side EF? If the answer is yes, then you've got it. Angle, side, angle. The triangles are congruent. Great job! You've already learned the 2 main rules. Now let's add 2 more very powerful tools to your geometry kit, SSS, and a special one called RHS. SSS is probably the easiest one to remember. It just stands for side, side, side. If you can show that all 3 sides of one triangle are equal to the 3 matching sides of another triangle, well, they have to be congruent. You don't even need to worry about angles for this one. And yeah, it's really as simple as it sounds. You just look at the triangles. If the first side of one matches the first side of the other, the second matches the second, and the third matches the third, that's all you need. By SSS, those triangles are congruent. And finally, our special rule, RHS. Now, this one is a VIP rule. It is only for right angle triangles. It stands for right angle, hypotenuse, and side. So if you have 2 triangles that both have a 90-degree angle and their longest sides, the hypotenuses, are equal, and one other matching side is equal, then they are congruent. Phew, okay. That's all the theory. You now know all 4 rules. But the best way to really learn is by doing. So come on, let's crack a typical exam problem together. Okay, here's the question, straight from your textbook. We have this shape, ACBD. The problem tells us 2 things. First, that side AC is equal to side AD. And second, that the line AB cuts angle A exactly in half. Our job is to prove that the top triangle, ABC, is congruent to the bottom triangle, ABD. Now, whenever you see a geometry proof question in your exam, what is the very first thing you should always do? Well, you should write down everything that is given to you. So let's look at the question again. What information did they give us? That's right. The problem gave us 2 very important clues. First, that the side AC is equal to the side AD. And second, that the line AB bisects angle A. And bisects is just a fancy word for cutting something into 2 equal parts. So it means angle CAB is equal to angle DAB. Okay, let's write out the proof. We're looking at triangles ABC and ABD. First, we have AC equals AD. That's a side, and it's given to us. Next, we have angle CAB equals angle DAB. That's an angle, and that's also given. Now, do we have another side? Yes, we do. Look at the line AB. It's part of the top triangle, and it's also part of the bottom triangle. So AB is equal to AB because it's a common side. And there you have it, side, angle, side. The triangles are congruent by the SAS rule. We did it! But hold on, the problem has one more little part. Now that we know for sure that the triangles are congruent, what can we say about the other 2 sides, BC and BD? Of course, they have to be equal. And why do we know that? Because of our amazing superpower, CPCT. Remember? Corresponding parts of congruent triangles are equal. Since the triangles are perfect copies, their matching sides, BC and BD, must also be equal. See how powerful this is? Excellent work. That was absolutely fantastic. Now, let's just do a super quick final revision of everything. Think of this as your last-minute cheat sheet for the exam. All right, here it is, your final cheat sheet. Just remember the 4 magic rules. We have SAS, side angle side with the angle squished in between. We have ASA, angle side angle with the side squished in between. Then there's SSS, the easy one, just match all 3 sides. And finally, RHS, your special tool just for right angle triangles. You got this. And just like that, you have revised the entire chapter. See? That wasn't so bad, was it? You are ready for your exams. I want you to go in there with a lot of confidence, do your absolute best, and make me proud. Best of luck, my dear students.